Hey guys, welcome back to my YouTube channel and you're watching Step Ladder, and I hope that you all are fine and good. And if you're not yet subscribed to my YouTube channel, then please subscribe my channel right now so that you'll receive amazing contents and videos that I will be uploading in my YouTube channel. And in this video we will be learning about the part 5 of your chemical reactions and equation series from your NCERT class 10 CBSE chemistry part. That is your chapter 1 of your science class 10th textbook. Okay guys, without much delay, let's start today's session. So in this whole session we will be learning about your displacement reaction. So this is your third type of chemical reaction, that is your displacement reaction or your single displacement reaction. So this displacement reaction, I guess you all might have learned already in your 7th standard. So a displacement reaction is a type of reaction in which a more reactive element displaces a less reactive element from its compound. So in this displacement reaction, a more reactive element displaces a less reactive element from its aqueous solution or from its compound, right? For example, if zinc is more reactive than gold, then zinc will replace gold in its aqueous solution. So that is your displacement reaction here. So as you can see here from this image, that A plus BC will give you AC plus B. So here the less reactive metal has been replaced, right? So in this image you can see it clearly. So this is your displacement reaction. Now let's see some examples for your displacement reaction. So the first example here is Fe2O3, that is your solid iron oxide combining with aluminium, that is plus 2Al, which is solid. Delta symbol, I guess you all can see, that is heat. So this equation, so you're heating that iron oxide that is combined with aluminium to get molten iron and aluminium oxide. So what is molten iron? So molten, in the sense, it is a liquid state of substance, that is you make a substance into liquid form by heating the substance. So that state is called as your molten state. Fine. So your molten iron that is liquid in state, that is your 2Fe plus Al2O3, that is your aluminium oxide. So this is the end product in this equation. So this example is for your displacement reaction as well as for your redox reaction, that is your reduction and oxidation. So as you can see here, that here reduction and oxidation also takes place in this first equation, right? So we will be learning about redox reaction in our upcoming classes. Fine. Now let's see the second example. 2Ki, that is your aqueous solution, that is your potassium iodide, is combining with your chlorine, that is your Cl2 gas, and the end product here is, so if you are combining potassium iodide with chlorine, you are going to get potassium chloride and iodine, that is your 2KCl, which is your aqueous solution, plus I2, which is your solid substance, that is your iodine. So this is an example of your displacement reaction as well as your redox reaction. Fine. As I said already, redox reaction, in the sense, it's all about reduction and oxidation process. Fine. So even you can see in this example that reduction and oxidation takes place in this second equation. So these are some examples of your displacement reaction. Now let us see some more example of your displacement reaction so that you can understand very clearly about this displacement reaction. So as I said that your displacement reaction is a chemical reaction in which highly reactive metal or substance replaces a less reactive metal in its aqueous solution or in its compound. Fine. So here you can see the example. Zinc is more reactive than copper, right? So in the reactivity series you can see that zinc is placed at the top and copper is at the end, right? So zinc is more reactive than copper. So zinc, that is your Zn, combining with your copper sulfate, that is CuSO4, will give you the end product as ZnSO4 plus Cu. So here zinc replaces the place of your copper. So instead of copper, it is zinc in this place. That is zinc sulfate plus copper. So copper becomes alone. So it's left out. Fine. So this is your displacement reaction. So your zinc is a silvery white compound and your copper sulfate compound, it is in blue in color. So your copper sulfate is in blue in color, and the end product here is compound of zinc, that is your zinc sulfate, which becomes colorless after the reaction, that is after your chemical reaction it becomes colorless, and your copper that is kept alone, that is left alone, becomes red brown in color. Okay, but if you take the second equation, that is copper plus zinc sulfate, there will be no reaction because already this equation is displaced because copper is in its correct place and zinc sulfate, that is ZnSO4. So this is all already correct, right? So copper is left alone and zinc, that is more reactive than copper, that is more reactive than your copper, has entered in the aqua solution, that is your sulfate. So it combined with your zinc with your sulfate, so that becomes your zinc sulfate, right? So this equation will have no reaction. So remember this equation, that this type of reaction will have, this type of equation will have no reaction at all. Now let us see the first activity given in your NCERT textbook for your displacement reaction. So if we learn this activity or understand about this activity, we can better understand about this displacement reaction. So we'll have better picture about this displacement reaction. So let's get into the activity 1.9. So in your activity 1.9, so this activity is basically about how the iron nails dipped in copper sulfate solution, what property they gain after they are dissolved in the copper sulfate solution. So this activity is basically based on this, and so to perform this activity 1.9, the required materials are 3 iron nails, a sandpaper, 2 test tubes, 10 ml of copper sulfate solution, and you will be requiring a thread. So these are the required materials to perform this activity. Now let's see what are the steps that are involved to perform this activity 1.9. So the first step here is take 3 iron nails and clean them by rubbing with sandpaper. So this is your first step. So you should take 3 iron nails and clean them using a sandpaper. So rub with the sandpaper so that you can clean the iron nails. Now the second step here is take 2 test tubes marked as A and B. In each test tube, take about 10 ml of copper sulfate solution. So you should take 2 test tubes, that is test tube A and test tube B, in which you should add 10 ml of copper sulfate solution. The third step here is tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for 20 minutes. So take 2 iron nails, okay, and with a thread you can immerse it inside the test tube B, which contains the copper sulfate solution, for 20 minutes, and keep 1 iron nail aside for comparison, right? After 20 minutes, take out the iron nails from the copper sulfate solution. So after 20 minutes, you should take out the iron nails from the copper sulfate solution that you kept already. Now compare the intensity of blue color of copper sulfate solution in test tubes A and test tubes B. Right, now you should compare the color of the copper sulfate solution in both the test tubes A and test tube B. Also compare the color of iron nails dipped in the copper sulfate solution with the one kept aside. So you should check whether the color of the iron nails changed after this reaction or not. Fine. So as you can see from this image that this is the diagram for your activity 1.9, and I hope that you understood this activity fine. So you can see here iron nails and copper sulfate solutions compared before and after the experiment. So this is before picture, and in the RHS side it is the after picture fine. So you can have a look on this picture. Now, why does the iron nail become brownish in color and the blue color of copper sulfate solution fade? Now, this is the question given in your NCERT textbook, that is, why does the iron nail become brownish in color? So, why the color of the iron nail changes to brown color and the blue color of the copper sulfate solution fade? So, why does it fade out? Fine. So here you can see the chemical equation is given here for this activity 1.9. You can see here Fe, that is your iron, which is solid, plus CuSO4, which is your aqueous solution, which is your copper sulfate, will give you the end product FeSO4, that is your aqueous solution, plus Cu, that is solid, that is your iron sulfate and copper. So you can observe here the less reactive metal has been replaced by highly reactive metal, right? So this is an example for your displacement reaction. So in this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as your displacement reaction. Fine. So why does the iron nail change in brown color? Because you are dipping the iron nail in the solution of copper sulfate, so the color of the iron nail changes after the reaction into brown color. So it turns out in brown color. Fine. Now let us see some other examples of your displacement reaction. That is Zn plus CuSO4, which is your zinc, that is solid in state, and your copper sulfate, which is your aqueous solution, will give you the end product, that is zinc sulfate, that is your aqueous solution, plus copper, which is solid. So here also you can observe that displacement reaction has been taken place here, right? So the highly reactive metal replaces the less reactive metal or displaces them. So this displacement reaction can be also called as single displacement reaction or single replacement reaction or replacement reaction or substitution reaction. So this displacement reaction has many other names. So remember those names, because these questions can also be asked in your board examinations. Now let us see the second example here, that is your lead, which is solid, combining with your copper chloride, that is aqueous solution, CuCl2, will give you lead chloride, which is PbCl2, which is your aqueous solution, plus copper. So here you can see the copper is left alone, which is solid in state. Fine. So zinc and lead are more reactive elements than copper. So in the reactivity series of metals, zinc and lead are placed at the top level and your copper is at the end. So zinc and lead are more reactive than compared to your copper, so they will displace copper from its compounds or from its aqueous solution. Fine. So this is your displacement reaction. Now you can see this reactivity series of metal. So you can see there is an arrow, so it goes up. So at the top you have most reactive metals, and at the down you have least reactive metals, that is your less reactive metals. So you can observe here that potassium is highly reactive than sodium, and sodium is highly reactive than calcium, and calcium is highly reactive than magnesium. But zinc is highly reactive than gold. Fine. So this is your reactivity series, and I have given here how to remember this reactivity series. So you can, for this I have taken the first letter of all your elements. So I have taken the first letter from their names, not from their symbols. So these are not their symbols. Fine. So these are the first letter or the second letters of your elements names. So you can remember this reactivity series. So you can see here, please, that is for potassium. S, that is for sodium. That is, please stop calling me a careless zebra. Instead, try learning how copper saves gold. So in this way, you can see that P is for potassium, S is for sodium, Cal is for calcium, and M is for magnesium, A is for aluminium, and Car is for carbon, Z is for zinc, and I is for iron, T is for tin, and Le is for lead, H is for hydrogen, copper is for copper, S is for silver. Fine. So here you will be like confused, like we have two S. So remember that you can even remember by taking the symbol of silver. Okay. So copper saves gold, that is, gold is for your gold. So in this way you can remember the reactivity series, and I hope that this will be helpful for you. Now let us see what are the types of displacement reaction. So there are two types of displacement reaction basically. So that is your replacement reaction and your metathesis reaction. So even your double displacement reaction is called as metathesis reaction. That is the other name for your double displacement reaction. And types of displacement reaction also has your metathesis reaction. Now let us see first what is your replacement reaction. See, reaction is nothing but it is the another name or the another terminology that we use to refer your displacement reaction. So here the definition is as same as your displacement reaction, that is a single replacement reaction, sometimes called a single displacement reaction, is a reaction in which one element is substituted for another element in a compound. That is, this is the same definition for your displacement reaction, that is a highly reactive metal displaces a less reactive metal in its compound or in its aqueous solution. So this is the definition for your replacement reaction. Fine, and I hope that you understood this replacement reaction. Now let us see what is metathesis reaction. So as I said before, that you can call double displacement reaction that we will be learning in the upcoming classes as metathesis reaction. So your metathesis reaction is a chemical reaction in which two hydrocarbons. So in metathesis reaction, so it is a type of chemical reaction in which two hydrocarbons. So from the word hydrocarbons itself you can understand it means that hydrogen and carbon. So hydrocarbons are substance that contains the mixture of hydrogen and carbon atoms. So your hydrocarbons are used in the form of crude oil or for some energy sources or for coal and other types of sources. So here includes alkanes, alkenes or alkynes. So these are nothing but, and you also have aromatic, right? So these are nothing but they are the types of hydrocarbons. So there are four types of hydrocarbons, that is alkanes, alkenes or alkynes, and also aromatic hydrocarbons. So these are your four types of hydrocarbons that you will be learning more in detail in your upcoming chapters. Fine, so I don't want to make you stressed now, so I'll teach you later about this hydrocarbons topic. So here two hydrocarbons, they combine in this chemical reaction to get two new hydrocarbons by the exchange of your carbon, that is by the exchange of your carbon atoms. Two new hydrocarbons they form. So here the exchange of carbon can be single bond or double bond or triple bonds. So it can be either carbon single, carbon double or carbon triple bonds. So usually here you require a catalyst. A catalyst is basically a substance that makes your reaction more effective or it increases the rate of your reaction. So that is your catalyst. So here it means that these are usually catalyzed by a catalyst. It means you catalyze something. so that you can make the reaction more effective, right? So this is your metathesis reaction, that is your other name for your displacement reaction as well as your double displacement reaction. Now I have added a GIF for your better understanding about your displacement reaction. So you can watch this GIF. So here you can see that iron, that is solid, combining with your copper sulfate, that is CuSO4, which is your aqua solution, will give you FeSO4, that is your aqua solution, plus copper, that is your solid. So here the single displacement reaction takes place. So here the highly reactive metal displaces a less reactive metal. So this is your example for your displacement reaction. Now let us see what are the other terms we use to refer for your displacement reaction. So these are the other terminology that we use for referring displacement reaction. As I said before, it is single replacement reaction or replacement reaction, metathesis reaction or single displacement reaction or substitution reaction. So these are the other terms of your displacement reaction. Now basically your displacement reaction are exothermic reaction. It means from the word exothermic itself you can understand exo in the sense outside and thermic, that is thermal, which means heat. So you evolve heat, you release heat out. So basically your displacement reaction is exothermic in nature, that is exothermic reaction. So remember this point. And now let us see a new terminology here, that is halides. So halides are basically a binary part, or they are a compound of your halogen. So they are a part of halogens. So halogens I'll talk later. So halides, they are a compound of your halogens. So halides are electrically positive. It means they have positive charge, they are positively charged. So they are called as electropositive ions. So they are ions, remember they are ions, and they are a binary or a compound of your halogen. Now let us see halogens. So halogens are electrically negative, so they acquire negative charge, so they are called as electronegative compounds. So you can find these halogens in your 17th group in your periodic table. So you can find these halogens in your 17th group, right? So these halogens include fluorine, chlorine, bromine, iodine and astatine, right? So these are some elements that are included in your 17th group in your periodic table. So these elements are named as halogens. So these elements are basically electronegative compounds in the sense they are electrically negative, they acquire negative charge, while your halides are electropositive, they are electrically positive and they acquire positive charge. So these are the difference between your halogens and halides are a binary, they are a part of your halogen. Fine. Now I have two questions for you, and I hope that you will be doing these two questions as homework. And if you can solve these two questions, so these are very simple questions. If so, if you are going to solve this question, then please comment your answer in the comment section. I'll check all your answers and I'll try to clarify all your doubts, and I'll try to revert all your suggestions. And if you have any doubts regarding this video, then please comment it in the comment section, or if you want to suggest something, please suggest it in the comment section. And if this video was useful, then please give this video a thumbs up. And I hope that you all understood this whole session. And in the upcoming the upcoming session, we will be discussing about your metathesis reaction, that is your double displacement reaction, which is your fourth type of chemical reaction in your basic types of chemical reaction. So these are the two questions that I am giving as homework. So if this video was very helpful and informative, please like this video, share with your friends, and please comment it in the comment section. Please subscribe my YouTube channel so that you will receive all the informative videos and notifications that I will be uploading in my YouTube channel. If you are not yet subscribed, please subscribe right now so that you receive the amazing contents and videos in my from my YouTube channel that I will be uploading in it. And please like, share and comment the video. Please do not forget to hit the bell icon. given below so that you'll receive all kinds of notifications from my channel. Please subscribe. Until then, bye bye. Meet you all in my next video, and I will be back with your fourth type of chemical reaction. Bye bye. Stay tuned, and please do not forget to subscribe my channel.